So real quickly, the last illustration that I showed you was actually not the current one. It wasn't quite up to date. So this is a better illustration. So again, typically, our lighting systems increasingly are looking like this. So we'll have our main console or backup console. And if we're using an Ethernet-based protocol, then it'll go into a switch. And from the switch, now the switch can either use copper, but there are switches that convert from copper to fiber. And the reason is that if you have a long run, an Ethernet cable, you really want to limit it to no more than about 200 to 250 feet. If you try to go more than technically you can go 100 meters, which is 328 feet. But if you try to go more than 250 feet, then there's a high likelihood that you're going to have problems. So if you need to go more than 250 feet, you have some options. One option is to use fiber optic cable, because fiber optic cable can go for literally miles and miles and miles. But you need a switch that converts from copper to fiber. So that allows you to go longer distance. And then you'll have another switch to convert from fiber back to copper. And then you'll have a gateway. And the gateway is a protocol converter. So in this case, we're converting from ArtNet or streaming ACN to DMX, which is the black cable. And then with DMX, you typically want to use a data splitter. So the data splitter is to break up your link. So you can daisy chain your DMX cable, but and you're able to connect up to 32 devices on one link, and we'll talk more about that later. But my preference is not to link too many devices together, because if you lose one data cable, how many fixtures are you willing to lose? If you have 32 devices in a single link and one data cable goes bad, you can lose up to 32 lights. That's a chance I'm not ready and willing and able to take in most cases. So what I typically do when I design a lighting system, I want to limit the number of fixtures that I put in a link, somewhere between 4 and 8. So that way, if I lose one data cable, I lose a maximum of 4 or maybe 8 lights. So we use data splitters for that reason. So if you look at a rig like this, you might want to put that truss on one link, put that truss on one link, that truss on one link. So you look at it logically and you break it up into pieces, and that way it becomes more reliable, it becomes easier to troubleshoot, and so there's a lot of advantages to using data splitters. Now in this model, these fixtures are taking DMX directly, but what's happening is that in some instances now, the lights, this gateway is going away, because the gateway that is external, in some instances, is now being put right into the fixtures. And the way you can tell if a fixture has a gateway in it is if you look at a fixture like, for example, the Elation Proteus hybrid, and you see an Ethernet connector. If there's one Ethernet connector on it, that means it has a built-in gateway. And remember, a gateway is a protocol converter. It's converting from ArtNet or streaming ACN to DMX. So if you put the gateway inside the fixture, now the fixture can take ArtNet or streaming ACN directly, and then you go to the menu to turn on the gateway, and it will output DMX. So now the advantage is, because DMX is a bus topology, that means you can daisy chain the cables, whereas Ethernet is a star topology. You're not supposed to daisy chain the cables. Some fixtures now even have 2 Ethernet ports on them. If you see a fixture that has 2 Ethernet ports on it, that means it has a built-in switch. So now you take this switch, you put it in the fixture, and the way you can tell is if there's an Ethernet input and an Ethernet output on the same fixture, then there's a 2-port switch inside of that fixture. So that switch is exactly like this switch right here, which allows you to distribute your Ethernet. But the advantage of putting a switch in here is now you've got an input and output, which means you can daisy chain the Ethernet cable. Now, you have to be real careful about that because every switch has some delay. It delays passing on the data. That's called latency. And if you have too much delay, then things start going wrong. So if you try to link too many fixtures, even if it has an input and output, you're going to run into problems, which I've seen before. So typically, again, if you have a built-in switch and you're trying to daisy chain the Ethernet cables, you really want very short runs. You want no more than maybe 4 fixtures to link together before you go to another link. Okay? So, now, yeah, question?
You're linked Ethernet to, say, make your home run being the first unit via Ethernet, and then you transfer that to DMX using it as a switch or as a node. What would be the length after that first home run? Because, as you said, if you were using Ethernet cable, there's no more than 250 feet.
Right.
What would be the length after that using DMX?
So with DMX, you can go up to about 1,000 feet, including all of the daisy chains. So it's pretty long. It's a pretty long way, and for most of us, we'll never run into that limit. But my feeling is, if you have a big system with a long run, then personally, I would look at whether or not wireless was a good option, because rather than run, say, 500-foot run of DMX, I'd rather try a wireless link. If you can do line of sight with no obstructions, that might be a good way to go. Okay, so but in practical terms, 1,000 feet, it's for most of us that's considered almost unlimited. Yes.
Richard, I'm sorry. One more time, you said Ethernet maximum cable length is how much?
Technically, it's 100 meters. If you look in the protocol, it'll say 100 meters. But in real life, if you go more than 250 feet, you're almost guaranteed to have problems. So in real life, you really should limit it to somewhere between 200 and 250 feet. Because the number one issue, the number one problem with most ArtNet or streaming ACN systems is the Ethernet cable is too long. Okay, so to avoid those problems,
Cat
just
5, Cat 6 doesn't matter. That's
right.
Okay.
Yeah. Well, it does matter. It does matter, but
Go Cat 6.
sorry.
You'd want to go Cat 6.
Yeah. Yeah. Okay. Any other questions?
And, sorry. Also, you said DMX 1,000 feet max. We've always kind of made it a rule of thumb here at Elation just to tell customers 300 feet before you have to go into a branch.
And you know what? I like that better because the longer your run is, the more problematic, the more problems you can run into. So especially for users that don't have a lot of experience, it's best just to say, hey, let's limit it, let's cut it off at 300 feet. Now, people with more experience, you might find that it works with a longer than 300-foot run. Technically, so DMX, and we'll go into this a little bit later on, but DMX is a protocol that we borrow from the computer industry. It's called RS-485. That's the serial data transmission protocol that we borrow from the computer industry. It's we didn't invent it. And technically, if you look at the specs for RS-485, what it says is you can actually transmit it 1,000 meters, which is 3,281 feet. But if you tried a DMX run that long, good luck. It's just, you're not going to have good luck. So there's nothing wrong with limiting it to 300 feet. And in most cases, 300 feet is plenty, right? But we're talking about every single fixture in the link, from the console to the last fixture in the link. Okay? Any other questions?
Rick, can I comment?
Yeah.
There are some companies out there that are using an RJ45 connector for just DMX.
Yes. Yeah.
You can't always go by an RJ45.
Good point. Yeah, good point. So Kevin, just to reiterate what Kevin just said, he said there are some companies that are using Ethernet connectors for pure DMX. Now, most of the time when you see an Ethernet connector, that indicates an Ethernet protocol or an Ethernet-based protocol like ArtNet or streaming ACN, but not always. In our industry, there are some fixtures to save real estate because the DMX connector kind of takes up some room. So if you don't have a lot of space on the fixture, some manufacturers are using that smaller Ethernet connector, which we refer to as an RJ45, and because it takes less room and it's cheaper. So you can't always assume that when you see an Ethernet connector, we're talking about an Ethernet-based protocol. You have to read the manual, and sometimes you'll find that that Ethernet connector is actually for a DMX signal. Thanks for that, Kevin. I think you had your hand up first.
Yeah. When would you know to either use the Cat 5 or Cat 6?
So, okay, later on, tomorrow we'll talk about the difference between Cat 5, Cat 5e, Cat 6, and Cat 6a Ethernet cable, and what the differences are. But the short answer is that the higher the category, the more bandwidth it has. So if you want to build the fastest network possible, and usually we do, especially if you have a big system, then you want to use you want to create the most bandwidth you could. So in that case, you would want Cat 6a. They even make Cat 7 cable, and they make Cat 8 now. So now I don't think it's necessary to go out and buy Cat 8 cable, but it's available, okay? Somebody else had their hand up? Yes?
Is that 250-foot run, is that from the start to the very end?
Exactly, to the last fixture in the run. So you daisy chain your signals from the console to the last fixture in that run. That's what we're talking about, the maximum length of the run, okay? Any other questions? Okay. So, digital multiplexing, or DMX means digital multiplexing. Now, multiplexing comes out of the telephone industry, and it's a way of transporting multiple channels over a single pair of wires. In the old days of telephones, before multiplexing, you had a telephone wire, and you had operators who would physically connect one phone to the other. So like, say for example, you have a hotel room with 100 rooms in it. There was a switchboard operator who would take the call coming into the hotel, and they would ask them, which room do you want to talk to? And they'd say, I want room 39. So the operator would take a patch cord and physically connect it to the phone, the wires that go up to room 39. It's not a very effective way of doing it. So much later on, they figured out a way to send multiple conversations over a single pair of wires. And the way it works is, suppose you have 10 telephones and 10 phones that you want to connect over a single pair of wires. So you take a multiplexer, and a multiplexer will sample the conversations in sequence over and over and over again, and it'll put a fraction of the conversation on those lines, and then on the other end there's a demultiplexer that reconstructs each of those individual conversations by sampling the signal and gluing it all back together. Now you lose some bandwidth that way, but in that way you're able to send 10 individual conversations over a single pair of wires. That's how you multiplex. Now, digital multiplexing just means that you can send 512 control channels over a single pair of wires. So that's why they call it DMX 512, because it's 512 control channels. There's actually a written standard for DMX. There's a document that spells out exactly how you're supposed to do DMX. And it's available for free now at www.tsp.esta.org. Now, it used to be that they charged for these standards. They were about $35 or $40 a piece, and there's a whole bunch of them. But DMX is one of them. And then after the Indianapolis accident several years ago, what was it, 8 years ago, 6 years ago, something like that, then the insurance companies, there were some standards, some staging standards that could have helped in that case. And so when the insurance companies looked into it and they found there was an existing staging standard, then the insurance companies wanted to make all the standards available for free to the industry. So they're actually paying ESTA. ESTA is the Entertainment Services Technical Association. They're the ones who develop standards. So the insurance company, ProSite, started paying ESTA so that we can all download all the standards for free. So take advantage of that. It's a great opportunity.
What was the accident?
So I think it was in 2010, there was a big rig at the Indianapolis State Fair, and there was a band that was going to play, and actually I think they were playing, but a storm blew through, and it blew the rig over, and it killed 7 people. and injured many more. And so that's when the insurance company started saying, well, isn't there a staging standard that could have prevented this? And there was, but you had to pay for it. So they made it available free of charge, along with all the other standards, including DMX. So now you can download DMX free and you can read it. Now, unless you are actually developing products, then you probably don't need this level of detail. You probably don't need to know everything that's in that standard, because the standard covers the electrical characteristics like the voltages, the impedances, and the circuit connections. It also covers the data format. You know, DMX is what's called a packetized protocol. So the data is sent in a packet, and the format spells out what the packet looks like. It also describes the baud rates and the cable type, the connector type. That's all spelled out in great detail in the standard. Now, for most of us, if we are users of DMX and we're not building DMX gear, then we probably don't need that much detail. In which case, there's another document that you can download from the same website, and it's called Recommended Practice for DMX 512 by Adam Bennett. So, Recommended Practice for DMX 512 by Adam Bennett. It's in its second edition. Adam works for ETC in London, and it's a great, it's not a very long document. It's more like a pamphlet. It's maybe 40, 50 pages long, and it's a smaller size. But again, you used to have to pay $40 for it. Now it's free. And it just describes best practices for DMX, how to get the most reliable system from when you build your DMX, which is basically what we want to talk about today. And we want to talk about some troubleshooting procedures and that kind of stuff.
What's it called again?
It's called Recommended Practice for DMX 512. It's in its second edition by Adam Bennett. And by the way, I have a list of all these resources on, I've got 4 websites. The one that has the resources, I think, is electrics.tech. So www.electrics.tech. There's a list of resources, including books and magazine articles and some other stuff. And that book, Recommended Practice, is listed in the list of resources. Okay? All right, now, so the whole goal when we set up a DMX system is we want to make it reliable. Now, DMX is pretty bulletproof. It is pretty reliable as long as you build it correctly and use the right components. And it all starts with cabling. You know, this is from Adam Bennett's book. He says a good DMX system starts with good quality cable of the right type. If system reliability is important, now in our industry, that's number one. We want it to be reliable. So if you take shortcuts and if you ignore the best practices, then you know, don't be surprised if you have problems. But there's no substitute for good cables and connectors correctly built and installed. So, and we're going to talk about later on. We'll talk about what constitutes good quality cable. There are specs you can look at that describe the requirements for DMX, and then we'll talk about what those specs mean. Okay. So now, first of all, a capacitor. Does anybody here not know what a capacitor is? A capacitor. Well, I'll describe it anyway. A capacitor is a charge storage device. It's a little electronic component, and if you were to open up the console or any of these fixtures and look on the circuit boards or any of your laptops, there's a lot of capacitors in there. They come in different sizes and shapes, but they're all pretty much the same. You know, the way a capacitor works is if you take a conductor, like say you had a copper plate, and you take a second copper plate and you put them really, really close together where they're almost touching. They're almost touching. But you insert an insulator in between, like a piece of plastic or mylar, in between, and you make a sandwich of conductor, insulator, conductor. And then if you were to solder some leads on it, and you connect those leads to a battery, what would happen is that that capacitor then would collect electrons and positive and negative charges. You'd put a charge on it, and then when you take the battery off, that capacitor is fully charged. It's charged up. You know, when I was in when I was in high school, and I took electronics class, we had a 2-year class, and you know how there's always that one kid in class who's always getting in trouble. You know, that was Ronnie, and Ronnie, we used to love to take. He would take capacitors that the teacher brought, because our teacher in high school in electronics class, he was a retired military officer, so he would go to the Army Navy supply store, and he would buy military spec capacitors. Military spec capacitors they're filled with oil, and they hold the charge really, really well. So this kid would take them, and he would charge them up as high as he could get the charge on them, and then he'd toss them down the hall to the art department, was next door, right? And he'd wait until somebody came out to sketch a sketch or something, and they'd see that, and he'd go, "Hey, can you toss that back here?" And if they picked it up just right and they got their fingers across the terminal, it'd shock the heck out of him. He just thought that was hilarious, you know? So that's an example of how capacitors work. You can put a charge on them, you charge them up, and they will hold the charge for a long time, you know? So to build a capacitor, all it takes is you have a conductor close to another conductor separated by an insulator. Well, that exactly describes a cable, does it not? Because you have a conductor next to another conductor separated by an insulator, and it's twisted together. Now, a cable is not a great capacitor, but it can have enough capacitance that what happens is that if you were to if you take a cable that has relatively high capacitance, and you want to send a DMX signal through it. Well, DMX is a square wave. So there's either voltage or there's no voltage, right? So when the voltage goes high, there's voltage input on the DMX cable. So if this is acting like a capacitor, what happens is when the voltage rises, this capacitor, so to speak, kind of slowly charges up, and then when the voltage drops, the capacitor slowly discharges. Now, the DMX signal is supposed to be a square wave, but if you have a cable that has relatively high capacitance, then it changes the shape to something that looks more like a sawtooth wave. And the data gets distorted, and then you get aberrations. You know, you might get like flicker or jitter if it's a moving light, or you know, the gobo might shake or something like that when it's not supposed to. So what the DMX specification says is that the capacitance from conductor to conductor should be no more than 19.8 picofarads per square foot. Now that's how you measure capacitances in farads, but a farad is a huge number, so a pico is 1/1,000,000th of a farad, or sorry, it's 10 to the 9, minus 9. So it's a very small amount. It's a very, very small amount. But this would be what you look up in the spec for the cable. So if you're going to build your own data cables, for example, then you would find a cable you think is suitable, and you'd look up the specifications for that cable, and you make sure that the capacitance from conductor to conductor is less than 19.8 picofarads per square foot. And then they also specify the capacitance from conductor to shield, which should be less than 35 picofarads per foot. Okay? And so, in order to minimize capacitance on a cable, manufacturers who make cable have very specific construction techniques and very specific construction materials. You know, they have the way they twist the wires together, the thickness of the insulation, the kind of shield they use, all influence the capacitance of a cable. And they have to pay close attention to that. So if you're a manufacturer and you're building a cable that is not high-speed digital data cable, like say, for example, a microphone cable. You know, an audio cable only has to transmit frequencies from 20 hertz to 20,000 hertz. That's the audio range. That's very much lower than DMX, which is 250,000 bits per second. So the frequency is much lower for an audio signal. So therefore, an audio manufacturer of audio cable pays no attention to the capacitance of the cable. It doesn't matter. So they'll build it anyway, any haphazard way, and you're almost guaranteed to have high capacitance cable, which is not good DMX cable. So if you want to build a good stable system, then don't use microphone cable, don't use audio cable to transport a DMX signal. Now, having said that, you know, if you find yourself in a situation, say you're out on a show and you run out of DMX cable, what do? You know what I do? I go to the audio department. I say, hey, can I borrow a cable? You know, yeah, you might be able to get away with one or two microphone cables or audio cables, but as standard practice, you don't want to use microphone cable as everyday DMX cable because it's not good for that purpose, okay? So the other thing it says is that the cable itself, if you're building your own cable, you want to make sure that it has a characteristic impedance between 100 and 120 ohms. What does that mean? Well, the characteristic impedance of a cable is the impedance of an infinite length of that cable. So first of all, what does impedance mean? Well, impedance is the opposition to the free flow of electrical current. And a DMX signal it boils down to electrical current. So how much does it resist that current flowing through the cable? Well, it resists it by this much, somewhere between 100 and 120 ohms. Now, an infinite length of the cable doesn't exist. There's no such thing. But when the manufacturer builds a cable, they can model it mathematically. They create a formula. There's a formula that they can plug in some numbers, and they can calculate the characteristic impedance of that cable, and then they'll put it up on the specs so you don't have to do the calculation. That you can just read it. So again, if you're building your own cable, you want to look at the specs and make sure that the characteristic impedance is between 100 and 120 ohms. And so this is a picture of a DMX works with integrated circuit chips that are called transceiver chips. A transceiver is both the transmitter and receiver in one integrated circuit chip. So they're 8-pin chips. They're little bitty things. They're very inexpensive. And this triangle represents an integrated circuit amplifier. It's called an op-amp. And so in DMX, there are two inputs. One of them is the actual data, and the other is what we call the data complement. And I'll show you that in a moment. But so the two inputs come in on twisted pair wire. And we use twisted pair. That's part of the specification for a DMX cable. It needs to be twisted pair wire. And then it outputs the signal. And this represents the load. And in this case, it's an infinite length of cable, so it's loaded to 120 ohms because that's the characteristic impedance of that cable. Okay? Now, the reason we want to use twisted pair wire, and that's part of the spec, is that this transceiver chip is what's called a differential amplifier. A differential amplifier, this amplifies the signal, but it doesn't just amplify both signals coming into it. It amplifies the difference between the two signals. So if you have and the reason is it's for noise rejection, because you know what? There's lots of sources of electromagnetic interference, EMI. You can't see it, but it's there. Look up. What do you see? I see fluorescent lights. Fluorescent lights, those are 4-foot tubes. So there's an electrode on one end, electrode on the other end, and there's an arc through gas in between. And that's connected to an alternating current supply, which means that the arc is actually going back and forth 120 times a second. It's flickering 120 times per second, too fast for your eye to see. But in the process of doing that, it's broadcasting this magnetic field around it. So if you could see the electromagnetic interference, you'd see that there's about a 3-foot radius of electromagnetic interference around those fluorescent fixtures. So that means that the cables, the DMX cables that are within 3 feet of that fluorescent light are getting bombarded by electromagnetic waves, radiation. And so that can get into the cable and cause interference. So if you have twisted pair wire, so first of all, it's also shielded. So one of the specifications is DMX cable should have a braid or a shield around it. That shield acts like what we call a Faraday cage. A Faraday cage shields out all that electromagnetic interference and it keeps less of it from getting to the conductors. But it's not perfect. So some of it will get into the 2 conductors. And the reason we want it to be twisted pair is because this is a differential amplifier, so it subtracts the 2 signals. And if it's twisted pair wire, that means that any source of electromagnetic interference will be picked up equally on both inputs, and it'll subtract out better, so you get better noise rejection. So that's why we use twisted pair wire for DMX cable, for noise rejection. And it works. So besides fluorescent lights, there are lots of other sources of electromagnetic interference, things like video walls and solar spots, radio and television transmission towers, cell phones. What else is there? There's Wi-Fi, there's radios, there's all kinds of stuff. If you could see all the electromagnetic interference, it'd be like a thick fog in here, So that's why we use twisted pair data cable with a shield or braid. Now the cable should also be 24 gauge or larger. Now in North America, we use the American wire gauge, AWG, American wire gauge. And American wire gauge is backwards because a bigger number means a smaller wire and vice versa. It's like, why do they do that, Well, and that used to drive me crazy. Like, why couldn't they just use, a straight common sense, But instead, one time I read about how they make wire. You know how they make wire? If you take a big blob of copper, like a billet of copper, and you squeeze it through a tool, and you extrude it like the old Play-Doh factory thing, if you extrude it one time, it might be so big. And then you take that wire, and you extrude it again, you make it a little bit smaller, and if you extrude it twice, that's number 2 gauge. And if you extrude it 4 times, it gets smaller, that's number 4 gauge, and then 6 and 8 and 12 and 24. So by the time you extrude it 24 times, it's very, very small. So now that makes sense to me, so I can sleep at night now, So, but anyway, so if you use wire smaller than 24 gauge, then what happens is there's too much resistance in the wire, and it doesn't transmit the signal well. So you want to make sure it's at least 24 gauge or larger. 22 gauge is recommended, and so that minimizes the voltage drop, but it also gives it more mechanical strength. Because we're tugging on these wires, we're coiling them up, we're tossing them in the back of our trucks, or in the back of our vans or whatever. So we need some of that ruggedness, reliability. Okay? So twisted pair, 120 ohm, shielded. Now, this is the Electronics Industry Association specification of 485. Yes, question?
I had a question on that last slide. Where's the transceiver in the chain?
Okay, so let's see. Can we get a PC board with the DMX transceiver chip on it? Okay, actually meant to bring some, but I forgot to pack them. I have some transceiver chips. So you can go online to Allied Electronics, or to my favorite is Adafruit. Adafruit sells all kinds of electronic components like Raspberry Pis and Arduinos, but you can buy an RS-485 chip, integrated circuit chip, They cost about a $1.85 a piece if you buy them in onesies, twosies. But it's a little bitty integrated circuit chip. So that's the transceiver chip. That would be both in the console and in the light. So if you look at where the console plugs in, if you were to open up the console and follow that back to the first circuit board that it comes to, that's the transceiver chip. Little bitty thing. Same thing with the light. Wherever you plug in the cable into the light, then the very first thing that it hits is a little circuit board with a little integrated circuit chip. That's the transceiver chip. It's got 8 legs, and 2 of them are the transmitter, 2 of them are the receiver, and then it's got power and ground, and not sure what the other 2 are for, but that's what those are. Does that answer your question? Yeah. Okay. So anyway, RS-485 or EIA 485 is the computer standard that we borrowed from the computer industry. If you look on your computer, your USB port, that's a serial bus port. That's a serial data port. That is an EIA 485 transceiver. So we just took that same standard and we reused it because we didn't want to reinvent the wheel. We put it in all of our lights. Okay. The required cable, now this comes from Adam Bennett's book. He says that the gauge depends on the length, but 22 gauge is recommended, 24 gauge is minimum. And of course, there's lots of sources for DMX cables. And again, you can buy finished DMX cables, and you can buy raw cable. You can buy a 1,000-foot spool of cable and some XLR connectors and just build your own cables. So if you learn, sorry? Or buy from Elation, yeah. Make sure it's Elation, exactly. So now this is from Adam Bennett's book. The recommended minimum gauge does depend to a degree on the length that you're running. I think that might have been a question earlier, but from Adam Bennett's book, so if you're going 295 feet or 300 feet, then you could use wire as small as 26 gauge. That's not my favorite because that wire is so small, it's not very rugged. So typically what you'll find is either 24 gauge or 22 gauge. With 24 gauge, you can go 1,000 feet, and he's saying with 22 gauge wire, then you can go 1,640 feet, which is 500 meters. So, yes?
But at that point, that's exceeding the recommended transmission rate or length for DMX, right?
Well, so the recommended length is 1,000 feet. That's with 24 gauge wire. If you have bigger wire, there's less resistance, less voltage drop, so you have a stronger signal, so you can go a bit further. So what Adam is saying is that the distance you can actually go depends on the gauge of the wire. Now, I say 1,000 feet because most DMX cable that I've seen is 24 gauge wire. Now, if we look, let's see, we should have asked Red to get some DMX cable. And it should say on the jacket, or if it doesn't say on the jacket, we might have to look up the specs. But my guess is that if you look at the DMX cable that you guys carry here, it's probably 24 gauge. Now, if that's not the case, then here's how you compensate accordingly. Okay? Does it say?
Yeah, 22.
22. So this is 22 gauge wire. Okay. So now this is, according to Adam, 2-pair low capacitance shielded professional data cable, 22 gauge wire. So, this is, I'll pass this around so you can compare it to the gauge of wire of data cable that you're used to seeing and feeling, But and also keep in mind that's got a jacket around it. So the thickness of the jacket is going to influence how thick the cable is. But I'm sure you've all seen data cable that's really thin, you know, really skinny. That can't be 22 gauge wire, right? So now this comes from Adam Bennett's book, Data Cable Examples. So again, this is if you are building your own data cable. Whoops. If you're building your own data cable and you want to buy a big spool of cable and terminate your own cable, there's a whole bunch of cable types that could be used for that, okay? So if you download and read Recommended Practice for DMX 512 by Adam Bennett, you'll see all those cable examples. Any questions? Okay, let's go ahead and take a 10-minute break then.